All right, let's take a look at this problem. And we're told that let VC at time 0 equals 60 volts. We want to determine VC, Vx, and I naught for t greater than or equal to 0. So you want to figure out what our voltage across the capacitor is, the voltage across this resistor is, as well as the current going this way. We want to solve for all those, and looks like we look at our circuit, we see we have a bunch of resistors and a capacitor. So, and there aren't any sources. This is a source-free RC circuit. Okay, so we know that it's a source-free RC circuit. We can use the equations given to us with regards to that. And one thing we know is that our time constant is going to equal to RC. We're going to use that in our equations later on. And from what we've defined previously, we can use the equations for the voltages as well as the currents to determine the other values. Okay, but the first thing we want to do, because it's a source-free RC circuit, we want to come up with an equivalent circuit that consists of our capacitor as well as our resistor. Okay, so we want to come up with our equivalent with our capacitor, and technically our equivalent is going to be this R here. Okay, so if we can come up with that, then we can solve for our equations here, our voltages. Okay, a couple things you want to remind yourselves of is that T equals RC when you have RC circuit, and then we know V of T is equal to V naught e to the minus T over tau. Okay, that's given, so let's just keep that on the side because we're going to use that. Okay, and then we also know that IR of T is equal to V of T over R, which equals V naught over R e to the minus T over tau. Okay, so all these are potential equations that will help us solve for this problem. Okay, so let's back up here and let's look at the RC circuit. Okay. First thing we want to do, we recognize that 12 ohms here and 12 ohms here are in parallel. So let me back up just a little bit. So essentially what we want to do is come up with this equivalent circuit. Equivalent circuit's going to be, if we take this terminal and this terminal, we're looking for the R equivalent to the left of the circuit, R equivalent here. So that's what we're trying to do to get this R equivalent. Okay, so we notice, like I was saying, that we have a 12 ohm and a 6 ohm resistors in parallel, and those two, once we combine them, are going to be in series with this 8 ohm resistor. So let's go ahead and do that. So our R equivalent is going to be the 12 ohms in parallel with 6 plus the 8 ohms, which is going to be in series. So we're going to have 12 times 6 over 18 plus 8, and that's going to give us 12 ohms. So that's going to be our R equivalent. So we figured out R equivalent here is going to equal to 12 ohms. Our C here is just 1/3 farad. Okay, 1/3 farads. Okay, so now we've figured out our equation. So what we can do is we can say, well, now we can figure out our V. This is going to be our VC across the capacitor. All right, and we know our equation is going to be V sub C of, dependent on time, is equal to V naught e to the minus T over tau. Again, that's from the equation we have on the top right here. and just a matter of substituting. So V sub C T equals V naught, in this case is going to be 60 volts. So 60 e to the minus t, and our tau here is going to be, our tau is going to equal our equivalent times our capacitor, which is going to be 12 times 1/3, and that's going to give us 4 seconds. Okay, so in this case our tau is going to be 4 seconds, so it's going to be t over 4. Okay, and this is going to be in volts. So we've solved for the first part. We have our capacitance there, voltage for the capacitor. So we figured this guy out. Let's now go to the next part of the problem. Next part of the problem is saying, well, we want to figure out what V sub x is. So let's scroll up just a little bit and then go back to the circuit. But now instead of putting it in the final RC version of the circuit, let's back up and just say, okay, we want it to be, because we need this guy here and this guy. So let's just redraw the circuit in this format where we have our 8 ohms here. We got plus or minus VC here. Okay. And we want to figure out what our I naught coming down here is going to be. Okay. And then this is going to be plus or minus Vx. In this case, this is going to be 12 in parallel with 6, which is going to equal 4 ohms. All right. So that's 4 ohms. We can go back and solve for Vx. And that's going to be V sub x is equal to 4 over 12 times Vc, and this equals 1/3 Vc, which equals 1/3 the equation we just came up with, 60 e to the minus t over 4, all in volts. Okay, so now we have, this is V sub x. Okay, the next part is solving for I naught there. Okay, yeah, solve for I naught. And then we have the equation for that as well. We can actually simplify this some more. Let's just say V sub x equals 20 e to the minus t over 4 volts. I can actually clean it up a little bit. Okay. And then solving for I naught, we know that our I naught of t is just going to be IC versus the time, and that's defined as C dV C over dt. Okay. So if we rewrite this, that's going to be 1/3, which is our C, d over dt. Okay. And our VC is going to be 60 e to the minus t over 4. Okay, and that's the voltage there in volts. But if we take the derivative of that, we get 20 times minus 1 over 4 e to the minus t over 4, and that's going to be in amperes. And then finally we can rewrite this as our I naught time is minus 5 e to the minus t over 4 amps, and that's our final part of this problem. So we've solved for our voltage across the capacitor, we've solved for Vx across the resistor, as well as the current I0 coming down into the capacitor there.